See the last part of this problem. So the setup is exactly the same in terms of the length is decreasing at a rate of 2 centimeters per second, width is increasing at a rate of 2 centimeters per second, and now in this one we want to know the lengths of what's happening with the lengths of the diagonals when L is 12 and W is 5. So that's our find when statement, and then we just need to come up with really what the equation is going to be. So we're going to find we're going to call this Z. So typically when we have some sort of diagonal, I like to call it Z. You can call it whatever you'd like. D is for diagonal or whatever, but as long as you're kind of consistent. So we want to find the change in the diagonal. So it's going to be, I want to find dz dt when the length is 12 centimeters and the width is 5 centimeters. So that's the setup for this. So I need an equation that is involving all of the values that I have here. So I know from the problem that the width is going to be 5, and the length is going to be 12. So, and I'm trying to find the diagonal. So if we look at this, hopefully you can kind of see it. If you don't, you'll see it many more times again, that this is going to be a right triangle. And really what I'm trying to find is the diagonal or the hypotenuse. So what I'm going to find here really is the change in the hypotenuse, knowing the change in the width and change in the the two legs basically. So all of that involves a Pythagorean theorem. So in this case, it's the width squared plus the length squared is going to equal z squared. And that's what I'm going to take the derivative of. So again, we're using our power rules for this to get the derivative of it. So it would be 2w. But again, I need to say that I've taken the derivative of w with respect to time. Same thing with L is going to be 2L dl dt. And then the last one is going to be 2z dz dt. Now what you're going to hear me say quite a bit is, are any of these constant, meaning do they not change over time? So in this one, they all do change, because what we're trying to do is we're trying to find dz dt, so that we don't know. We currently don't know z, but we can find it because it's it's the diagonal, and I know that this is 5 and this is 12, so I can find z pretty easily. You should know it is already. dl dt we know, L we know, dw dt we know, and w we know. So we really know everything except for what we're trying to find, which is dz dt. And once I plug everything in, you can find dz dt. So I'm going to leave that up to you to figure out the rest, and we can talk about it in class.